Very good morning to everyone who's watching this video, including our dear lecturer, Dr. Haslina. We are from Grade 2, and for the subject SKN 2013 Artificial Intelligence, we're developing the facial recognition system. The team members for this group is Zhi Xian, Derrick Saw, Chong Kar Min, Tracy, Liaw, and Wei Jie. My name is Tracy Liaw, and I'm going to give a brief introduction on our system as well as guide through the first frame during a demonstration. Starting from a brief introduction, our system is called Facial Recognition System, where the system is able to recognize the identity of individuals through testing images or live video camera. There is a combination of different algorithms used in the system, including CNN, ResNet, and KNN. The dataset consists of 3,514 images from 101 entities and 1,500 testing images. So that's all for the brief introduction of the system. For demonstration, we'll have 3 different frames, including the dataset measurement frame, encoding and embedding frame, and lastly the run frame. This is the interface for the dataset measurement frame. There will be a list of different entities shown on the screen. The user is able to delete any entity from the system by simply clicking on a file, and after pressing the delete button, the file will instantly disappear from the dataset. The user can also add new dataset into our system with this add button. For instance, we want to add video games to our dataset, so we can click on the add button. A file chooser will immediately pop up for us to browse through our device. After picking the file and opening it, we can see the name appearing in the name list. If it doesn't, we can click the refresh button to refresh this frame. So that's all for the dataset measurement frame. Next, I'll pass to Wei Jie for the other 2 frames.
Good day, madam. My name is Wei Jie with matrix number 289669. And I'm going to explain the embedding and encoding function of our system. This function is actually based on the deep face recognition model with version 1. The system will actually take an image in a dataset to do a reference and convert it into a vector of 128-dimensional face descriptor. Then the system will return a list of 128-dimensional face encoding for each image. For the test function of our system, we design it into 2 parts. On the left side is the file selection side, where we can add new testing image or delete any image. For this project, we import a total of 1,500 image for us to do the testing function. To select it into testing phase, we can click on the file to choose a single image or highlight the others if we want to test multiple images. For the right part is the output part, where after we select the file on the left side, we can click on the test button to display the result. For the multiple image tested, we can click on the next or previous button to display different image we tested. And also the cam test button will function as a real-time face recognition, as it will trigger the camera of our device to switch on and display the identity of the member detected by the camera. For example, the system successfully recognized the identity of Derrick when he is detected by the camera. So that's all the function about our interface. The next part will be presented by my other group members. Thank you.
Thank you, Wei Jie. My name is Zhi Xian and my metric number is 284333. Now, let's see the Python coding for extract and embeddings. First, we need to import required packages such as the immutals, face recognition, and OpenCV installed. We are using up-pass to pass command line arguments. For the dataset in line 11 represents the path to our dataset, while encodings in line 13 tells that our face encodings are written to the file that these arguments point to. In line 15, we use the detection method to detect faces in image before we can encode them. Line 21 uses the path to our input dataset directory to build a list of all image paths contained therein. For line 24 and 25, we initialize 2 lists before our loop, which is non-encodings and non-names. We are looping over the paths to each of the image on line 28. This loop will cycle 3,504 times, corresponding to our 3,504 face images in the dataset. From there, we will extract the name of the person from the image path on line 32. Then, let's load the image. The face recognition modules uses dlib, so let's swap color spaces on line 37. Line 41 and 42 actually find the faces of the image, resulting in a list of face boxes. Then, we are going to turn the bounding boxes of the face into a list of 128 numbers on line 45. This is known as encoding the face into a vector. Line 56 construct a dictionary with encodings and names. From there, line 57 to 59 dump the names and encodings to these for future recall. That's all from me. Thank you.
Thank you, Zhi Xian. My name is Chong Kar Min, number matrix 2X7173. Now I will proceed our presentation on the Python code of recognized by images. First, we will import the necessary packages and the date time. Construct the argument parser and pass the arguments below. Load the node faces and the embeddings. Load the input image and convert it from BGR to RGB. Then it will detect the faces in the input image and compute the facial embeddings for each face. For this line, it will initialize the list of names for each face detected. In the face recognition compare faces function, it will look over the facial embeddings in attempt to match each face in the input image to our known encodings. If it has found a match, it will return true. And then for this, it will find the index of all matched faces, then initialize a dictionary to count the total number of times each face was matched. For this tree line, it will look over the match indexes and maintain a count for each recognized face. For this line, it will determine the recognized face with the largest number of votes. And lastly, it will update the list of names. Then look over the recognized faces, and we will use the box coordinates to draw the rectangles and the predict face name on the images. Lastly, we will store the result of output image to a folder, namely record. That's all for me. I will pass it to Derrick Saw.
Good day, madam. My name is Derrick Saw Wei Heng, and now I'm going to talk about face recognition by video. At first, we will import the necessary package, and then the argument will be passed to this Python file when it's called. Afterward, the known faces and their embedding will be loaded from a bigger files, which is produced during the encoding phases. At this line of code, the camera will start to open, and the video stream will start. We will look over the video stream and read the frame. The frame will be resized to 750 pixels to speed up the process of getting their embeddings and encoded back to the respective faces. Afterward, each Canon algorithm will look over the facial embeddings and attempt to match its faces in the input image to our known encodings. If there is a match, we will store them in a list. We will look over the match index and maintain a count for recognized faces. The recognized faces with the largest number of votes, and its identity will be taken as the final output. And then the name will be appended to the list. Afterward, we will look over the recognized faces and rescale the face coordinate. We will draw a rectangle besides the recognized faces and put their names at the side of the rectangles. At this stage, the writer will be initialized to write the output video to a disk, and if the argument display is bigger than 0, we will also display the frame to a window, and this window will be shut down if Q is pressed. After Q is pressed or window is shut down, the writer will be released and the whole system will be shut down.
So that's all from Group 2 for our facial recognition system. Thank you.